Which one is greater? In the A part, we have 2 raised to the power of 7 or 4 raised to the power of 3. Now 2 raised to the power of 7 can be written as 2 into 2 into 2 into 2 into 2, 1, 2, 3, 4, 5, 6 and 7 times 2 into 2 into 2. So if you solve this, you get 128. Now if you take this 4 raised to the power of 3, then this is 4 into 4 into 4, and you get 4 times 4 is 16, and you get 64. So clearly 128 is, since 128 is greater than 64, therefore 2 raised to the power of 7 is greater than 4 raised to the power of 3. In this one, 10 raised to the power of 4 can be written as 10 times 10 into 10 into 10 into 10, or it can be written as 1, 2, 3 and 4. So the number of power this base is raised to, that is 4, you can simply put those many zeros here. So here it is 4 power, so put 4 zeros after 1. So this is 10,000. Now write for this one, this is 100 squared. So this can be written as 100 times 100. And if you multiply this, you get, again, we have 4 zeros. So 1, 2, 3 and 4. So this is 10,000. This is also 10,000. So clearly these two numbers are actually equal. Therefore 10 raised to the power of 4 is equal to 100 raised to the power of 2. In the second problem, we have expand a cube b squared, a square b cubed, b square a cubed, b cube a squared. Are they all same? So after expanding, you have to tell whether they are all same or not. So let's do the first one. The first one is a cubed b squared, and if you write this as, this is what, a cubed into b squared, right? So this is a into a, then this multiplication sign, then b into b. Take this second one, that is a squared b cubed. So this is a squared into b cubed. This becomes a into b into b into b, right? Now take this third one, that is b squared a cubed, and you get b squared into a cubed, and this becomes b into a into a, right? And this fourth one is b cubed a squared. So this is b cubed into a squared. It means b into b into b into a squared, sorry, a into a. Now look at actually this first one, that is, if we put a's together and then these b's together here, and if you look at this one, right, you can clearly see that here we are multiplying a 3 times, here also we are multiplying a 3 times, and here we have we are multiplying b 2 times, and here also we are multiplying b 2 times. So clearly these two are actually equal. That is, if you look at this one and this one, it's actually a cubed b squared, and this is b squared a cubed. And if you remember, in our earlier videos we have discussed that when we are learning about factors and all, that the order of variable doesn't matter. This is just like if we say this is equal. Why? Because here it is a cubed, here also it is a cubed, Here it is b squared, here also it is b squared, just the order is reversed here. Here a cubed is coming first, here a cubed is coming after b squared, right? The only thing is this. And if you have to better understand this, let's take a very simple thing, like if it is 2 into 3, this will be actually equal to 3 into 2, right? Any difference? No, there is no difference. Same thing in the algebra also with variables. The main thing is that the number of variables should be same. So here we have a and b both, and then the individual variables should be same. Like here we have to multiply a 3 times, here also we are doing the same thing, and b 2 times, here also we are multiplying b 2 times. So these two are actually equal. And then if you look at this one, we are multiplying a 2 times, here also we are multiplying a 2 times, here we are multiplying b 3 times, and here also we are multiplying b 3 times. So if you look at this one and this one, it's actually a squared b cubed, and this is b cubed a squared. These two are actually same because we have seen here, this we can see here, and here again we have two variables only, a b, here also b a, and if you take the numbers, a is raised to the power of 2, here also a is raised to the power of 2, here b is raised to the power of 3, here also b is raised to the power of 3. Order doesn't matter, what matters is the number of variables and then the number of individual variables. Okay. Express the following numbers as a product of powers of prime factors. Okay, so this is 432, right? So in this 432, we have to write this in the form of prime factors, and it should be in the form of powers. Okay, that is, it should be in the form of exponents. So this is 432. If you do the prime factorization of 432, you get 2, 2, 4, then 200 and 260. Then if you do for this one, you get 2, 108. Then if you do for this one, this is 54. And for this one, you get 27. Then this is 3, 9, and 3. Right? So if you look at this one, we can write this as 1, 2, 3, 4, 1, 2, 3, 4. So 2 into 2 into 2 into 2, right? Group them together. Then into 3 into 3 into 3. This becomes 2 raised to the power of 4 into 3 raised to the power of 3, right? So this is, you can clearly see that here it is the prime product of powers of prime factors. Powers of prime factors. 2 is raised to the power of 4 into 3 raised to the power of 3, right? Let's take next one, that is 1000. So for 1000, either you can simply proceed in the way we have done just for 432, or let's take some different approach. This is 1000. This can be written as 10 into 10 into 10, right? This much is clear. Now each 10 can be written as 2 into 5. Then this one also 2 into 5. Then this one also 2 into 5. Now this is actually what? 2 into 5 into 2 into 5 into 2 into 5. How many times we are multiplying 2? Let's group them together. So it is 3 times. So 2 into 2 into 2. Then into how many times we are multiplying 5? So we are multiplying 5 3 times. So this gives you 2 raised to the power of 3 into 5 raised to the power of 3. Right? Okay. Now let's solve for 16,000. Again, you can either proceed in the way we have done for 432, that is prime factorization method, that is simple one, or let's take different approach as we did in this case. This is 16,000. Can we write it as 16 into 1000? Right? If we multiply 16 with 1000, we get 16,000. Okay. Can we write this 16 into 1000 as 16 into 10 into 10 into 10? Because this 1000 can be written as 10 into 10 into 10, right? Any confusion? I hope so. No. Then, if you write this 16 as 2 into 2 into 2 into 2, 2 into 2, 4, 2, 8 to 16, right? Then each 10 as 2 into 5, then 2 into 5, then 2 into 5, right? Now, here we are multiplying 2 4 times, then 5 times, then 6 times, and 7 times. Group all the 2's together. So multiply 2 7 times. 3, 4, 5, 6, and 7 into how many times we are multiplying 5? We are multiplying is 3 times. So this becomes 2 raised to the power of 7 into 5 raised to the power of 3. Right? Simplify. 1 raised to the power of 5. It means what? Doesn't matter how many times you multiply 1 with, you're going to get back 1 only. Right? So this will be 1. Now in this case, you have minus 1 raised to the power of 3. It means that minus 1 times minus 1 times minus 1. So first let's group these together. Let's multiply these two minus 1 together. So minus 1 times minus 1 means that it's 1. So 1 times minus 1. This gives you what? Minus 1. Right? Now look at this one. This is minus 1 times minus 1 times minus 1 times minus 1. So multiply these two together and then these two together. So if you do this, you get 1 times 1, that is 1. Now here's the thing. This is minus 1 raised to the power of 3. This is minus 1 raised to the power of 4. 3 is an odd number and 4 is an even number. So whenever minus 1 is raised to the power of an odd number, okay, any odd number, then you will get minus 1. And if minus 1 is raised to the power of even number, then you will get plus 1. Right? That's the thing. In fact, whenever you are multiplying any number, let's say that we denote this any number with variable a. Minus a can be any is an arbitrary number. If this is minus a, and if you are raising this base to the power of an odd number, if this minus a is raised to the power of odd number, you have to put minus sign for sure. And then whatever you get after multiplication a that many times. Like if I show you, if this is minus 10, or let's say if this is minus 4, if this is minus 4, if I raise it to the power of 3, now this is an odd number, so clearly put here minus sign and then simply multiply 4 3 times. So 4 into 4 is 16, into 4 is 64, right? It's true for any number. In the same way, if your minus 4 or any minus a, which is an arbitrary number, is raised to the power of an even number, you for sure your number, the result will be always positive. Since we don't need to mention plus sign, so whatever you get here will be positive always. Like if this is minus a raised to the power of 4, let's say, sorry, minus 4 raised to the power of 4. So no need to put minus sign here. You simply multiply 4 4 times, right? 4 4 times. right? So whatever answer you get here, that will be the answer of this one. Okay, now whatever we have discussed here, same thing will be here. This is minus 10, so clearly minus 10 is raised to the power of an odd number, that is 3. So for sure we are going to have minus sign. So put minus sign, then 10 times 10 times 10 is what? 1000. In this case, clearly we have an even number, so we are not going to get negative outcome. It will always be positive. So it means that you simply have to multiply 5 4 times and you'll get the answer. I'm just expanding it so that you have to show these steps in your examination. So if you solve it, you get 5 times 5 is 25. Then 25 times 5 is 125. 625. Right? If you multiply 5 4 times, you get 625.